Today we're solving problem 19 from the Spring Amc 10B from 2021. Suppose that S is a finite set of positive integers. If the greatest integer S is removed from S, then the average value, arithmetic mean, of the integers remaining is 32. If the least integer S is also removed, then the average value of the integers remaining is 35. If the greatest integer is then returned to the set, the average value of the integers rises to 40. The greatest integer in the original set S is 72 greater than the least integer in set S. What is the average for all the integers in set S? So let's just do substitution to make this a lot easier. On substitution, let's use variables. So we let the sum be A. Let the greatest integer in the set be BG, because it's the greatest. Now let the lowest, I'll just write least, because that's what the problem says, least, BL. Now we can write a system of equations for what the problem gave us. If the greatest integer S is removed from S, then the average value is 32. So the sum be A minus the greatest integer G over, we call the number, so let's just let the number of numbers in the set be n minus 1. Since you're removing one here, you have to remove one here. Since you're removing one, removing the greatest, this is 32. If the least integer in S is also removed, then the average value of the integers is 35. So A minus G minus L over n minus 2, since you're taking away the greatest and the least, this average is going to be 35. If the greatest integer is then returned to the set, the average value rises to 40. So now, basically what they're saying, if the greatest integer returns, so this is just A minus L over n minus 1, it rises to 40. And we also have another one. The greatest integer in this set, this is going to be the least plus 72. Okay? From here, we can actually start solving this problem. We can first multiply all this out. So we get A minus G. This is 32n minus 32. Same thing here. A minus G minus L. This is 35n minus 70. And we can do the same here. A minus L. This is going to be 40n minus 40. Okay, we can actually solve for n because we can use this equation. When we plug in the value for G here, this further becomes A minus L. Then you want to add the 72 to the other side. This is 32n plus 40. Now we have both of these terms in A minus L, so we can set them equal to each other. 40n minus 40. This is equal to 32n plus 40. Therefore, we get that n is equal to 10. The amount of numbers or integers in this set is equal to 10. So we have this value for n, but we want to find, well, we have the number, we just want to find A. What is A? Well, we can actually sort of plug all these values in. Let's just do it for this one. A minus G minus L. When we plug the value for n in, this is A minus G minus L. This is going to be equal to 350 minus 70. And why I write it like this and not when you directly subtract it is because when we put in the value of G back in here to get a different value. So when we do that, we get that this is A minus 2L. Then again, there's that minus 72. This is going to be 352. because when you add the 70 to this other side, this makes 2. Okay, so we have an a minus 2L here. We can make that equal to this one by subtracting an L on both sides. So this becomes a minus 2L. This is 40N minus 40 minus L. So we could just basically subtract an L from both sides on this and further solve. At this point, it's basically just solving it. And now I forgot to plug in the n equals 10 in this equation, but it's fine. We can do it right now. So this is a minus 2L. This is going to be equal to 360 minus L. Well, now these are now both expressed in terms we can further solve for. So this is a minus 2L, 352 is equal to 360 minus L. L equals 8. And further solving for A, we get that A is equal to 368. Now we have the sum, and we have the number of numbers. So what we have to do is divide 368, because that's the sum of the numbers, divide by the number of numbers, 10. This is 36.8. And we are done.